Make sure you pause the video and have a good read of the question, but this is a classic binomial one tail in the lower tail hypothesis test. Now get into the habit, however the question's worded, of doing these in the same order every time, and then you won't forget stuff. First thing we do in a hypothesis test is we write down the null hypothesis. Now for a binomial hypothesis test, that's for the value of p. We're given in the question that the value of p is 0.32. And we're testing at the 2.5% significance level whether there's evidence that the drug is effective in a lower proportion of patients. So less than 0.32. So that is our H1. Now do not proceed until you've defined P. There's no definition of P in the question, so you can't use a P in statistics without saying what it means. And there are marks for this. The simplest way of doing that in this question is to say that P is the proportion of patients for whom drug B is effective. You might want to though write where P is the probability that a randomly selected patient has drug B effective for them. But it's a bit fiddly to write that. So P as a proportion is usually much easier and more efficient to write than a probability. Next is to talk about an X. So we create a capital X and we define it. So X is always the number of, and in this case it's the number of patients for whom drug B is effective. And X is binomially distributed with n is 1,000 and P is 0.32. Now then you can use the experimental result, which is 290, and just think for a moment before you jump in and go any further. Remember, 290 is below the expectation. The expectation would be 1,000 times 0.32, which is 320. So 290 is in the lower tail as it should be for this test. So we're testing. We want to find the probability that X is at least as extreme as 290. In other words, less than or equal to 290. Your calculator in the binomial CD mode with these three parameters will give you 0.0221, which you need to explicitly show is less than the significance level. So this is a significant result. It's unlikely enough for us to reject H0. And don't forget to give a conclusion in context at the end. There's evidence to suggest that drug B is less effective. Don't write drug B is less effective, because we don't know that for sure. All we've got is some evidence from this trial to show that. You can never be certain about anything like this, but you can just find evidence for it. Now, just before I finish, I will show you just another way of calculating this probability. You will have learned, or you should have learned, that when you're doing a binomial, when using binomial distribution, if n is large, then you can use a normal approximation. There's no need to do that here because your calculator quickly works this out for you. But some candidates will use a normal approximation here just from force of habit if n is large. So I'll just show you that you do get the same result if you do that. There's the phrase to use if sometimes questions say, why are we allowed to use a normal approximation here? And you just need to write that there. N is large. Our normal approximation is X is normally distributed, NP is the mean, and the variance is NPQ, where Q is 1 minus P. So NP, using our N and our P from here, gives us these two values, 320 for the mean and 217.6 for the variance. And then if you stick those in your calculator, don't forget that this is the variance. You will need to square root 217.6 to get the standard deviation, sigma. But you get the same result. You get the probability is 0.021, which is, well, it's close. It's not exactly the same because it's an approximation, It's very close to this, but you're still going to reject h0. So your last 3 lines of working, which I haven't written here, would be exactly the same as these here.